September 4, 1944. Near the Albert Canal, Belgium. German engineer officers studying reports from the retreating front encountered a frustrating pattern. Again and again, bridges that should have delayed the Allied advance were failing to do their job. The German army had spent years perfecting the art of demolition. As Allied forces pushed across France and into Belgium after the breakout from Normandy, engineer units blew bridges, cratered roads, and destroyed critical river crossings. The logic was simple. Every destroyed bridge would force the enemy to stop, reorganize, and spend precious time searching for a way across. Time was Germany's most valuable resource. Yet something strange was happening. Allied armored columns kept moving. Rivers that should have created major obstacles were being crossed with astonishing speed. Reconnaissance reports described heavy trucks, artillery batteries, and even tanks appearing on the far side of waterways only hours after German demolitions had been completed. For German commanders, the situation made little sense. A river crossing normally required extensive planning, specialized equipment, and favorable conditions. Destroying a bridge was supposed to buy days, sometimes weeks. Instead, the Allies seemed capable of replacing entire bridges almost overnight. The answer was not a new tank, a secret weapon, or a revolutionary aircraft. It was a bridge. More specifically, it was the Bailey Bridge, a deceptively simple modular structure developed in Britain before the war. Built from standardized steel components, it could be transported in pieces, assembled by engineer units in the field, and strong enough to carry some of the heaviest vehicles in the Allied arsenal. To many German engineers, the Bailey Bridge represented something deeply troubling. It transformed rivers from defensive barriers into temporary inconveniences, and in modern warfare, that ability would prove every bit as important as the tanks crossing over it. But the story begins with a German strategy that had worked for generations, and why, by 1944, it was beginning to fail. Throughout military history, rivers have been among the most effective defensive obstacles on the battlefield. Unlike trenches or fortifications, they were natural barriers that could not easily be bypassed. A wide river forced attackers to concentrate at crossing points, making them vulnerable to artillery, machine guns, and counterattacks. For German planners during the Second World War, rivers offered something equally important: time. As Allied armies advanced across Europe in 1944, German commanders increasingly relied on delay tactics to slow the enemy's momentum. Orders frequently directed engineer units to destroy bridges before withdrawing. Roads were mined, ferry crossings were sabotaged, entire transportation networks were systematically dismantled behind retreating forces. The goal was not necessarily to stop the Allies permanently. It was to slow them long enough for new defensive positions to be organized farther east. This strategy had proven effective in many previous campaigns. During both world wars, damaged infrastructure often created major operational problems. Building a heavy-duty bridge capable of supporting tanks usually required specialized equipment, extensive preparation, and favorable conditions. Commanders expected rivers to create bottlenecks that could disrupt entire offensives. German engineer formations, known as Pioniere, became highly skilled in demolition operations. As Allied forces approached major waterways such as the Seine, the Meuse, and numerous canals throughout Belgium and the Netherlands, retreating units often destroyed bridges moments before withdrawing. On paper, the logic remained sound. An army moving hundreds of thousands of vehicles could not simply leap across rivers. But by 1944, German planners were facing an opponent with resources unlike any they had encountered before. The Allies were not merely advancing with tanks and infantry. Behind every combat formation stood engineer units specifically trained to overcome destroyed infrastructure at extraordinary speed. The result was a growing mismatch between German expectations and battlefield reality. And again, commanders discovered that crossings expected to delay the enemy for days were being reopened in hours. And the reason traced back to a quiet innovation developed years earlier by a British civil servant who had never intended to revolutionize modern warfare. The man behind one of the most influential military innovations of the war was not a famous general, weapons designer, or industrial magnate. He was a British civil servant named Sir Donald Bailey. Before the war, Bailey worked for the British War Office as a civil engineer. He was familiar with existing military bridge designs and understood their limitations. Many temporary bridges required specialized machinery, complex construction methods, or highly trained personnel. Under combat conditions, these requirements could become serious obstacles. Bailey believed there was a better solution. His concept was remarkably simple. Create a bridge from standardized steel components that could be transported separately and assembled almost anywhere using ordinary manpower and basic tools. In 1940 and 1941, as Britain prepared for the possibility of invasion, the need for rapidly deployable military infrastructure became increasingly urgent. Bailey developed a modular system built around prefabricated steel panels. These panels could be connected in different configurations depending on the width of the river and the weight of the vehicles expected to cross. The design offered several major advantages. Individual components were light enough for small groups of soldiers to handle. Sections could be assembled on one riverbank and then pushed across to the opposite side. Most importantly, the bridge could be strengthened by adding additional panels, allowing it to carry increasingly heavier loads. Extensive testing followed. British engineers subjected prototype bridges to trucks, artillery pieces, and armored vehicles. The results exceeded expectations. The structure proved strong, flexible, and relatively easy to construct under field conditions. Production soon expanded across Britain.
Factories
began manufacturing vast quantities of standardized parts that could be shipped wherever Allied forces operated. Because every component followed the same specifications, damaged sections could be replaced quickly, without custom fabrication. What began as an elegant engineering solution soon became something much larger. The Bailey Bridge was no longer simply a bridge, it was a system. One designed to give Allied armies the ability to maintain momentum even when every road ahead appeared blocked. The real test, however, would come not in British workshops, but on active battlefields stretching from Italy to northwest Europe. The Bailey Bridge looked simple. That simplicity was precisely what made it so powerful. When Allied armies in a destroyed crossing, engineer units could move into position with truckloads of standardized bridge components and begin construction almost immediately. Unlike many earlier military bridges, the Bailey system required no heavy cranes or elaborate machinery. Trained soldiers could assemble large sections by hand. The process was designed for speed. Engineers first constructed bridge sections on the near bank of a river or canal. Rollers were then placed beneath the structure, allowing crews to gradually push the growing bridge outward over the water. As additional panels were added, the bridge extended farther until it reached the opposite bank. Once secured, decking and roadway sections were installed, and traffic could begin crossing. The system proved itself repeatedly during the Allied campaigns. In Italy, where rivers, valleys, and mountainous terrain constantly disrupted movement, Bailey bridges became essential tools for maintaining offensive momentum. Engineer units frequently rebuilt crossings destroyed by retreating German forces, allowing troops and vehicles to continue advancing through difficult terrain. The same pattern emerged after D-Day. As Allied forces broke out of Normandy and raced across France, engineer formations followed closely behind combat units. Whenever bridges were demolished, replacement crossings appeared with remarkable speed. What German commanders expected to become major obstacles often became short delays. Some Bailey bridges reached impressive dimensions. During the war, engineers built versions capable of carrying heavy tanks, including the American M4 Sherman, and later heavier armored vehicles. Certain crossings stretched hundreds of feet across rivers and canals, demonstrating the flexibility of the design. More importantly, the bridges changed operational tempo. Every hour mattered during a fast-moving campaign. If a river crossing could be restored in hours rather than days, armored columns could maintain pressure on retreating forces before they had time to establish new defensive positions. And that is where the Bailey Bridge became more than an engineering achievement, because every bridge built at the front depended on a vast industrial machine operating far behind it, one that German intelligence increasingly struggled to match. By 1944, the Bailey Bridge had become far more than a piece of military equipment. It was the visible end of an enormous logistical system stretching from factories in Britain and North America to engineer units operating on the front lines. Every bridge panel, transom, roadway section, and support component was manufactured according to standardized specifications. Unlike many German engineering projects, which often relied on specialized designs and limited production runs, the Bailey system emphasized interchangeability and mass production. That difference mattered. When a bridge component was damaged, engineers did not need to wait for custom-built replacements. New parts could be delivered from existing stockpiles. The same components worked across countless bridge configurations, simplifying maintenance and reducing delays. The scale of production was staggering. British factories produced tens of thousands of bridge panels during the war. The United States also manufactured Bailey Bridge components in large quantities after adopting the design. By the time Allied forces returned to mainland Europe, enormous reserves of bridging equipment were available to support advancing armies. For German intelligence officers, the implications became increasingly clear. Destroying a bridge no longer guaranteed a meaningful delay. Every demolished crossing simply triggered a predictable Allied response. Engineer units arrived. Components were unloaded. Construction began. Within hours or days, traffic resumed. This capability amplified the effectiveness of every Allied formation. Tanks could continue advancing. Artillery could maintain support. Supply trucks carrying fuel, ammunition, and food could remain close behind combat units. The bridges themselves were not offensive weapons, but they enabled every offensive weapon that crossed them. The result was a form of mobility that Germany struggled to counter. As the war entered its final phase, German commanders increasingly recognized that Allied strength extended far beyond superior numbers. The true advantage lay in an industrial and organizational system capable of solving battlefield problems faster than they could be created. And nowhere was that reality more visible than during the retreat across France, Belgium, and into Germany itself, where German engineers began witnessing the consequences firsthand. By the autumn of 1944, German engineer units found themselves fighting a losing battle against time. Throughout France and Belgium, retreating forces continued to destroy bridges in accordance with long-established military doctrine. Rivers, canals, and waterways were expected to slow the Allied advance and create opportunities for new defensive lines. Instead, those obstacles were disappearing with alarming speed. The problem became especially evident during the Allied pursuit following the breakout from Normandy. German commanders hoped that successive river barriers would force Allied armies to pause repeatedly. Yet reports arriving from the front often described the same frustrating pattern. Bridges demolished one day were carrying Allied traffic shortly afterward. For German engineers, this was not merely a tactical setback. It represented the collapse of a core assumption about how modern armies operated. Historically, major river crossings consumed valuable time. Defensive plans depended upon that delay. Commanders could reposition units, establish artillery positions, and organize counterattacks, while attackers struggled to restore infrastructure. The Bailey Bridge dramatically altered that equation. As Allied forces approached the borders of Germany itself, engineer units routinely established these over canals and rivers that German planners expected to hold for far longer. The speed of these operations undermined carefully prepared defensive schemes and reduced the effectiveness of demolition efforts. The effect extended beyond engineering. Every successful crossing accelerated Allied operational tempo. Armored units remained in pursuit. Supply convoys stayed close to advancing troops. Artillery and reinforcements arrived without the lengthy interruptions that German planners anticipated. By late 1944 and early 1945, Germany faced a growing reality. The Allies possessed not only superior material resources, but also the organizational ability to convert those resources into battlefield momentum. Destroying infrastructure could still create difficulties, but it no longer guaranteed meaningful operational delays. For many German engineers, the lesson was unmistakable. The bridges themselves were impressive, but what truly made them dangerous was the system behind them. A system capable of turning rivers, once among warfare's greatest obstacles, into little more than temporary interruptions. And that realization helps explain why a simple steel bridge earned such an outsized place in the history of the Second World War. When people think of the weapons that won the Second World War, they usually picture tanks, aircraft, battleships, or artillery. Few think of a bridge. Yet the Bailey Bridge became one of the most important force multipliers of the entire conflict. It was not feared because it destroyed enemy forces. It was feared because it allowed Allied armies to keep moving. Every time German engineers demolished a crossing, Allied engineer units could often restore mobility before the delay achieved its intended effect. That capability transformed the battlefield. A tank division is only effective if it can advance. Artillery is only useful if ammunition can reach it. Supply trucks must cross rivers just as surely as armored vehicles. The Bailey Bridge connected all of these elements into a single, uninterrupted system. For German commanders, this created a frustrating reality. Defensive lines built around rivers and demolished infrastructure became increasingly difficult to sustain. The obstacles remained, but their strategic value steadily diminished. The true significance of the Bailey Bridge was not engineering alone. It represented a broader Allied advantage: the ability to combine innovation, industrial production, logistics, and organization into a unified war-winning machine. By 1945, that machine was rolling steadily toward the heart of Germany, and in many places, it crossed the final rivers of the war on bridges assembled from simple steel panels designed by a British engineer years earlier. Sometimes history is changed not by the weapon that fires the shot, but by the bridge that allows an army to keep moving forward.